so what do we need to know about lines? Well, most of the lines 101 comes back to graphing, because we're going to do a lot of graphing of these trig functions. And there's two things that we might want to know in terms of graphing. And I put this under lines 101, but really it's graphing. One is the go-to whenever we're not sure what's happening is graphing by plotting points. And we need to do this typically in a clever way, especially when we're thinking forward towards what we're going to do with trig functions. But let's just look at an example for a linear function. So let's do y is equal to 2/3 x plus, we'll do minus 4. Right, so if we were to graph by plotting points, some of you may already be going, that's a silly way to do this, let's not do that, but I'm going to do it anyways. We would set up an xy table. So x's, y's, and we're going to plug in x's to figure out what the corresponding y's are for our graph. So here's where being clever comes in. If I plug in, say, x is equal to 1, then I'm going to have to do 2/3 1 minus 4. I'm going to have a fraction on my hands, and that is not what I want, especially when I'm going to have to go graph something. I really don't want fractions in my graph. We're not going to be able to avoid them when we get to the trig graphs, but for now, we can. So if we're going to be smart about what we're choosing for our x values, we're going to notice that x is going to be multiplied by 2/3, which means it's going to be divided by 3. So every number we want to choose for x should be a multiple of 3 to avoid having fractions. So 0 is always nice. In fact, that'll get rid of that fraction really easily. But then instead of going 1, 2, we're just going to jump to 3. And let's go ahead and put 6 in the mix as well. So if we plug in 0, my y equals is 2/3. I know this is being slow for many people, but that's why you can fast forward me. Times 0 minus 4. So that first piece is 0, that first term, and then we'll just have a negative 4. If we plug in 3, we'll get 2/3 times my 3 and minus 4, which will give me, okay, the 3's will cancel, 2 minus 4, which is negative 2. And the last one will have 2/3 times 6, which will give me 12 over 3, which is 4. So we'll get 4 minus 4, which is equal to 0. And here's another thing I just have to point out because it's what I love about math. If you look here, there's a definite pattern going on. In fact, if we went one more, we'd notice this pattern even more. To get from 4 to negative 2, we added 2. To get from negative 2 to 0, we added 2. So I already know what the pattern is. To get to the next term, or the next y value, I would add 2, and that would be 2. And then we'd see the same thing going on over here, plus 3 each time as we move forward. So this would be my 9. So 9 would have a 2. And I can go backwards the same way. So patterns are what makes math beautiful. And then if you recognize this too, you'll notice this plus 2 corresponds to the change in y in my slope, and this plus 3 corresponds to the change in x in my slope. So it all makes sense and there's patterns going on. It's not a bunch of rules. So graphing this guy, we'll put in our points. The first one is 0, negative 4. So there you are. I'll even label it for you, 0, negative 4. Our next point is at 3, negative 2. And our last point is at 6, 0. And obviously we could also have 9, 2, and so forth. And then we're going to go ahead and connect these with our line showing where our beautiful thing is going. And of course, there's the other piece to this, that you don't have to make a table and plug in points. If you know some of the rules about lines, you know that we have, first off, our y-intercept is negative 4, so that we would start at negative 4, and then we would use that rise and run of our slope to rise 2, and then run 3. Rise 2, oops, that was the wrong color. Not that you could tell, because they're orange and yellow, because I have not changed my colors back to two things that are very different. And then we would run 3 again. So we've got this little rise and run business happening. Same thing, just a different way to get there. But this is also going to be true when we get to our trig graphs in terms of looking at amplitude and phase shift. There are some rules that we can memorize, but of course we can always fall back to plugging in smart values into a table. So that'll get you through all of the stuff with lines in terms of graphing them. The only thing that's not really covered in this that you have to do in that Delta math homework is there are times where you may have a, what was I thinking? Like 3x plus 2y is equal to 7, something like that. And this kind of combines what we were just talking about with the linear equations with our Lines 101, and that is we may have a question where it asks you to take this and it asks you to solve for y. Now sometimes you could just plug in values of x to see what happens to y, but it generally makes more sense to just solve for a variable. And again, this is similar to our solving linear equations. We look at where y is and we go, let's isolate that thing. Let's solve and simplify and get this by itself. Now, in the fractional lines that we had, there were a bunch of x's, so we had to kind of clean things up and then move them to the same side using addition and subtraction so we could combine them. But in this case, we want that y by itself. So if we were to solve this for y, we would notice there are two things happening. One, 3x is being added. There's no reason it needs to happen in this order. We could rewrite this. It's the same thing. And then it makes it more clear that this 3x is being added to that term of 2y. We can also see that there's a 2 being multiplied by that y that we want to get by itself. So we need to deal with two different pieces to get the y by itself. And like I said, we're going to reverse the order of operations to undo this. So first things first, we're going to subtract the 3x. We could divide by 2 early. That's fine. I'm not going to say dividing by 2 is bad. In fact, I'll go ahead and try to get rid of the 2 first over on this other side. So you can see that either would work. So I'm going to divide by 2. Here's the deal though. When we do something in an equation, we have to do it to the entire side. So that's why the division by 2 is typically something we have to do later. But if we subtract, we're subtracting 3x from the entire side by just doing it that one time. And then we'll do a minus 3x over here. That gets us, in fact, I'll give us a little like divider, our two sides being dealt with. So in this case, the 3x plus 3x and minus 3x, those things cancel each other. That was the whole point of that move. So we are left with 2y is equal to, again, you can write it however you want. Typically, we write the variable first, but there's absolutely no reason. If you want to leave it like this, you can. It doesn't really matter. If we're thinking about moving towards slope-intercept form, though, we might want to move it with the x in the front, because usually it's mx plus b. So we'll do that. Making sure that the negative stays with the 3x and that the 7 is still positive. And then we can go through and divide by that too. And again, we're dividing the whole side. So your final answer, if you move this way, is y is equal to 3/2 x plus 7/2. Now, I distributed that division. Division is the same thing as multiplication, so I distributed the division by 2 to both sides. That's completely okay. And here's another thing I love to talk about because I think it's something students don't always recognize. The negative can be anywhere. It's the same thing as 3 over negative 2, and it's the same thing as putting the negative out in front of 3/2. Your choice is just whatever makes the most sense to you. In my case, the negative was on the 3, so I just kind of left it there. If I solved this the other way, from the other side, again, I would have done that split move. So the 2 and the 2 would cancel here. That was the whole point. I have 3/2 x is equal to, oops, I'll change my plus to an equals, 7/2. And then I recognize the only thing happening now to that y is this addition. I keep trying to change my color and failing. And so if I want to get rid of the addition, I'm just going to subtract. And ooh, gross, now there's, oh no, it doesn't matter. They're not like terms, so I don't have to deal with the fact that there's a gross fraction going on. So here I'm to the exact same point, y is equal to negative 3/2 x plus 7/2. At this point, though, I could see a lot of students multiplying by 2 to get rid of the fractions, and so they would just sort of end up in this weird cycle, not realizing what they had done. But like I said, lots of different ways to get to the same thing. The biggest thing with our lines is really just recognizing we can always plot points if we're not sure what's happening, but there are a lot of times rules that make it a lot classier than having to go through all of this grunt work of graphing points.